Okay, we have here today another integral. This one's from MIT Integration Bee 2020, number 12. We have the integral from 0 to pi over 2 sine 2x cosine of cosine x dx. Okay, I think there must be multiple ways on this one, even though I only looked at one way. What I want to do first is we want everything to have the same angle. Here we have double angle. Here we have single angle. So for sine 2x, we can just write this as 2 sine x cos x. And then from here, I think we're set up for a u substitution. The thing is, we don't really want cosine inside the cosine, so that's really the first thing I want to deal with. So I'm going to make that my u. So we'll say u is going to be cosine x, and then du is going to be minus sine x dx. So maybe let's set it up so we're clear about what's happening. So we've got the integral from 0 to pi over 2, brought the 2 out as a constant. Then maybe I'll split this apart a little bit. Like we'll leave one cosine here. Then we're gonna have cosine x, take this sine, bring it over here. To set it up exactly, let's create this minus sign like this, and so that I don't change it, let's bring another minus sign out front. So we're just multiplying by 1. And now we're all set up for the u substitution where our du is gonna be over here. I kind of squeezed it in, but that's gonna be the du. So when we do this, we have minus 2. Plug pi over 2 in here, cosine pi over 2, that's going to be 0. Plug 0 and cosine of 0 is 1. Cosine of x is u. Here this becomes cosine u, and again, everything's du. We'll take this minus right here. We'll just use it to swap the bounds. So now we can write this as going from 0 to 1. But this right here, this is going to be set up for quick integration by parts. We'll do the DI method over here, differentiating u, integrating cosine u, and we'll do it fast because this comes up a lot. So for u, we can differentiate this down to 0, just differentiating twice. Over here, integral cosine u is going to be sine u. Do it again, we get minus cosine u. Put that together with solution on the diagonals. Last row is zeroed out by the 0. We're going to have 2 u sine u for the first part. Here, minus times minus is plus cosine u, all evaluated from 0 to 1. Then let's see if I can kind of sneak the answer in down in this area. So we're going to plug in 1. It's not going to simplify nicely because because sine of 1 is just sine of 1 and cosine of 1 is just cosine of 1. So what we have is, it's just going to be sine of 1 plus cosine of 1. Thinking of that angle in radians, like on our circle, if like pi over 3 is right here. So like pi over 3 is a little bit greater than 1. So for like 1, it's going to be like kind of something like this. So basically to get a value for these things, you're going to need a calculator. But then moving on to the 0 part, we're going to have minus, you plug 0 and this first piece goes away, you plug in 0 to here and you just get a 1. And so for my final solution on this, we just have 2 times sine of 1 plus cosine of 1 minus 1, and that's it. Okay, so there you go. I kind of like it when that happens and we can't simplify it, so we just leave it like that and call it good. Okay, so there you go. Nice quick one from MIT 2020. Thanks everyone for watching. Have a good day.